Hello and good day. I am Richie J. Reyes from 11th STEM del Mundo. Let's learn about the rules of differentiation and the chain rule of differentiation. Before we begin, let's note down the notations that we will be using. We have f prime of x, d all over dx, or derivative with respect to x of the function, y prime, and finally, dy all over dx, or derivative of y with respect to x. Note that the constant will always be 0. For example, the derivative with respect to x, we have y is equals to 4. Then, the derivative of y with respect to x of our 4, since 4 is just a constant, automatically this part is equal to 0. Now that's all clear, let's go on with our set of rules. Let's start with the power rule. Let n be a non-zero constant. For this, we will use the formula of the derivative of x raised to n is equals to n times x raised to n minus 1. First example, y is equals to x raised to 4. Start off by writing dy over dx is equals to derivative with respect to x. We will be writing the x raised to 4 on the right side. Our n is equals to 4, which, according to our formula, we will bring down n, then multiply to x. The exponent, we will be subtracting it by 1. Then we will simplify. Now, we have dy over dx is equals to 4x cubed. Now that is our final answer. Next example, x raised to negative 6. Same goes with the first example. Let's bring down negative 6 times x raised to negative 6 minus 1. Simplifying it, we have negative 6x raised to negative 7. Now that is our final answer. Moving on to our next rule, the constant multiple. Let's have c to be any constant and f of x to be any function. Let's have our formula. Derivative of a constant multiplied to the function. For this, we can place our constant outside of our derivative operator. We will be using this to find our derivative. First example, 4x squared. Starting off with dy over dx is equals to the derivative with respect to x. Then write down the 4x squared. Now, let's apply our formula by putting our constant outside our derivative operator. Now, we have 4, derivative with respect to x, then write down the x squared. Finding the derivative of x squared, we have to copy 4 first, multiply it by 2, write down x raised to 2 minus 1. Simplifying it all together, now we have 8x. Up to our next rule, the sum and difference. Given the function f of x and g of x, the derivative of their sum and difference is defined by the derivative of f of x plus or minus g of x, which means we can separately get the derivative of both terms as long as we retain the signs between them, which is the plus or the minus. For example, 4x cubed plus 2x. Following the formula, dy over dx is equals to 4. Bring down the exponent, which is 3. Multiply by x raised to 3 minus 1 plus 2 multiplied to 1 times x raised to 1 minus 1. Simplifying it, we have 12x squared plus 2. That will be our final answer. Moving on to our next rule, the product rule. Just remember, first function times the derivative of the second function plus the second function times the derivative of the first function. For example, dy over dx is equals to the quantity of x squared plus 4 times the quantity of x cubed minus 2. Following the formula, we now have the quantity of x squared plus 4 times 3x squared plus the quantity of x cubed minus 2 times 2x. Simplifying it, we now have 5x raised to 4 plus 12x squared minus 4x. That is our final answer. For our last rule, we have the quotient rule. We will be following this formula. F of x is equals to g of x all over h of x, where h of x is not equal to 0. Remember, low d high minus high d low all over low low. Let's have this for example. 4x plus 3 all over x cubed plus 2. Following the low d high minus high d low all over low low, we have the quantity of x cubed plus 2 times 4 minus the quantity of 4x plus 3 times 3x squared all over x cubed plus 2 squared. Simplifying it, we now have negative 8x cubed minus 9x squared plus 8 all over x cubed plus 2. Now that is our final answer. Now we will go to our next topic, which is the chain rule of differentiation. Given the composite function y is equals to f of g of x, we let the inner function g of x be equal to u. Following this formula, dy over dx is equal to dy over du times du over dx. For example, y is equal to the quantity of 2x squared plus 3 raised to 9. Let us determine our u as the inner function 2 plus 3. And our y is equal to u raised to 9. Let's now start by writing down dy over dx is equal to the derivative with respect to u, write down u raised to 9. Then, times the derivative with respect to x, write down the quantity of 2x plus 3. We will apply the power rule here, which will become 9u raised to 9 minus 1. Then, we will multiply this to the quantity of 2 times 1x raised to 1 minus 1 plus 0. Simplifying it, we now have 9u raised to 8 times 2. Distribute 2, we now have 18u raised to 8. Going back, we have our u which is equal to 2x plus 3. We now copy this to our answer. Now, it will become 18 times the quantity of 2x plus 3 raised to 8.